Cool. Okay. So this is the complex numbers and calculus. Just going to go through a few questions. Any questions or anything at any point, just ask. So we'll start off with the Cauchy-Riemann conditions. So these conditions are, we can see in the questions, we've got du by dp is dv by dq, and we've got du by dq is equal to minus dv by dp. Those are the two conditions which are known as the Cauchy-Riemann conditions. The question is just asking which of those are true for this function f. So our function f works on complex numbers. It's got a real part and a complex part. We can see this, the real part is q to the 4, so we can say that get the pen working.
You have to click the squiggle.
Yeah, got it. So u is q to the 4, and v is p squared. So that's u being the complex part, no, the real part, and v being the imaginary part. So this is what we start off with. We need to work out du by dp, du by dq, dv by dp, and dv by dq. So we start with the easy ones. Du by dq. That's just differentiating this, which is just multiply, reduce the power, 4q cubed, and dv by dp. It should be deltas, not d's, but I can't really draw a delta. Just gives us 2p. Again, multiply by the power and reduce. And then we do some partial differentiation to get du by dp. Remember, anything, when we do partial differentiation, anything that isn't the variable we're looking for, then we just treat it as a constant. So q here is just a constant, and q to the 4 is a constant. So when we have a constant in differentiation, we just lose it. So this just gives us 0. And dv by dq. Differentiate v with respect to q. Same here, p squared is just a constant because we're doing partial differentiation with respect to q. So we just lose it. There's no q's, so we just got 0. So we can see here that 4q cubed is not the same as 2p. We don't know what they are, so it's possible they could be the same in a certain situation, but they're not always the same. We'll actually be comparing to negative. So 4q cubed is not the same as minus 2p. And then we've got du by dp is equal to dv by dq. They're both 0. So that's true. So it doesn't satisfy all the conditions. One of them is it's this one. It's not both, and it's not that one. So it's just doing those 4 differentiations, 2 of them partial differentiations. The top 2 are kind of also partial differentiations if you had some p's in u and some q's in v. They're all partial differentiation, but this one's a fairly easy one. We don't need to worry about that. So there we go.
So this next one, which of the following choices corresponds to the Euler form of the complex number z equals 4 plus 3i? So the approach for this type of question is that we want to convert 4 plus 3i into Euler form. A couple ways you can do that. There's calculators which will do it directly, though sometimes they'll have it in a different format. You won't always actually have the cos in the exponent. You'll just have a number, a theta, an angle. It seems that Euler form has different forms. The one Paul uses, which is with the trigonometric function in there. Others which don't have it in there. Another way to do it is to convert these into polar form and then find the one of these which match their the result of doing either sine -1 with the number or cos -1's number. Do the inverse of these numbers and find the one that matches the theta given by polar form, which is what I'll do. So we're using 4 plus 3i. We need to find that in polar form. We can use that using Math Portal. Where's my mouse? So we want to look at, where is it? I'm blind. Complex. There. Complex, we want to be doing, I think it's this one? No, is it the top one? Yes. So we want to turn this into 4 plus 3i. I'm going to compute that. That will give us this. This is the polar form of that. I see this 37 degrees. That's our theta. So we want to find the one of these which match 37 degrees. And if you stick that in a calculator, you go through cos -1 for all of them, and so we'll sine. For example, this one is 41. So this first one is 41. Rounding, because the calculator will give a lot more detail than the no decimal places given by this, given by the calculator. And if you go through, the one we want is 0.8. So inverse cos is 0.8, which is this one. I get this. That is huge. There. We want this one because it's the one that matches the polar form theta, and Euler form polar form are linked in that way, in that the theta, which is in the exponent, will always match. Next one. Given the complex numbers u equals 2 plus 3i and v equals 2 minus 3i, which of the following describes the complex number w, which is u times v? Multiplying complex numbers, you can do it manually, do a calculator. I'm showing the calculator routes because it's easier and we're allowed. Oh yeah, that does remind me. So if we can find a way to handle sharing with everyone, we will also share these live as well, so people can grab these screenshots as well as afterwards if they want. That's what Elliot's doing. Yeah, so we want to find out what u plus v is, u times v is when it is 2 plus 3i and 2 minus 3i. Again, we can go Math Portal for that. We want to go into binary, and it is 2 plus and 2 minus 3i. We are timesing them, so we want it to be multiplying. We want to compute, and that'll spit out 13. And that's our answer, 13. So this one would be this last one, 13. Oops. Squish. That one. Next one. Given the complex numbers v equals 8 minus 2i, which of the following describes the complex number w equals 1 over v? This is the same concept. We're going to do the same thing, really. The major difference is that we also need to keep track of, we need to remember that 1, it can be expressed as a complex number, which is 1 plus 0i, which just gets rid of the imaginary part. And now let's use the same calculator for it. So if we go back here, we can do, what was it? It is 8 minus 2i. and it is 1 first. So for this one, go back down to this, it is 1 times 0i, and then 8 minus 2i. Is that correct? Yes, it was. And we want to be dividing them. Compute. And we get this. Now, this doesn't look like any of the answers, so we can go back a couple of steps, and we see we have this. 8 plus 2i divided by 68. We come back here. Oops. We have this. None of these match up, because the other one's 68, the other one's the square root. But because we have 2i, we can divide the whole thing by 2. And we get 4 plus I over 34. 4 plus I 34 is this one. The answer is the third one. We can simplify the expression a bit and see that this one is the answer.
What's the difference between that and the bottom one?
Oh, the minus. This one has minus, this one has
Oh,
plus.
yeah, that's it. Thank you.
Okay, this one. A shared 3D printer is able to process PR of X items of output every day. In this function, PR of X is based on the number of units X a user's X simultaneously attempting to use it, and described by that function, which is PR of X equals 75 times X squared minus 10 times X cubed. If there are too few users, the expense of the equipment cannot be justified. If there are too many, then there's too much of a weight. What value of X describes the optimal performance, i.e., what value of X maximizes that function. So we want to find the maximizing of this. Oh. There. What we have is a polynomial. We're trying to optimize the polynomial for maxima, so we want to find the maximum of the polynomial. Matplotlib has a thing for this. If we go to polynomial calculators, and I believe it is in graphing, and then local maxima and minima, we want that equation in. It was 75 times x to the 2 minus 10 times x to the 3. I'm going to graph the polynomial. There's our answer. And what you get is that the maxima is when y is 625 and x is 5. And that's what we're asking for. What x value generates the maxima? That would be 5. So our answer is 5. In fact, I'll screenshot this. That's a bit big. Shrinking it down. Okay. So our answer is 5. This one. Okay. It's getting a bit small. Make it bigger. Okay. A sequence of complex numbers, Zn, is defined by Zn plus 1 equals the current Zn squared plus 0.75. Okay, so this one works like so. So this is the equation. We start with of z0 of negative I. So z0 equals negative I. So z1, therefore, is equal to z0 squared plus 0.75. And that equals negative I squared plus 0.75. Then z2 then must equal negative I squared plus 0.75 squared plus 0.75. And what we want is the size of the resulting complex number. And what we can do is just spit that equation into something like Wolfram Alpha, and we can find the answer for it. We're going to go Wolfram Alpha. This is a bit more useful in some situations than others. I have it written down, so I have to write it all out. There we go. So negative I squared plus 0.275 squared plus 0.75 is our Z2. Put it through, and the answer. Wait, I think I missed a bracket. Yes, I did. And the answer is 0.8125. There we go. And then we can see 0.8125 is this one, this second one. Okay, next up. Oh, this one. Yeah. This one took me like 30 minutes to figure out because for some reason I kept typing in wrong without realizing. Fourth time's the charm. Okay, so this one is a student devises an algorithm for attempting multiple choice questions based on 3 components. Q is the number of questions involved, C is the number of choices per question, and X is the number of hours the student is prepared to revise for the exam. The student is trying to find X. The following function is what describes X. So we have the number of questions times by the natural log of X squared minus 10 times the number of choices per question times by the natural log of X cubed, all of which is then divided by 100. We are told that Q equals 40 and that the each question has 5 options. So C equals 5. So essentially what we need to do is put this into Wolfram Alpha, and with the relevant things switched over. If we do that, we get the notes up so I can copy it without having to switch back and forth all the time. There we go. Where's my mouse gone? There it is. Okay, it is 40. I'm going to put this in brackets. 40 times the log of X squared minus 10 times 5 times the log of X cubed, all then over, that should be at 1, all then over 100. And if I didn't mess anything up in typing that, we should get, if we scroll down, we will see that God damn it, I messed up writing it. Now rather than continually try and write that up, I will just take the handy screenshot I prepared earlier of what it would look like. Oh no, there we go. So if you were in Wolfram Alpha, you would be looking in the oh no, I did do it right. I was looking in the wrong section. Never mind, I'm a dum-dum. I was looking in the wrong area. I did do it right. Yeah, so you want to look at the local maximum, because we're trying to find the, as the question states, we're trying to maximize their score based on the X. So what X gives the maximum score. And if we look here, local maximum is when X equals e to the 8/15. We look through, that's this one, because X is ours. So it's that one. Next up, using arithmetic modulo 10, which of the values below describes a principal fourth root of unity for the purposes of implementing the 4-vector Fourier transform? Okay, so for this, essentially there is a the idea is that you want to find something that matches this format. Let me just copy it. So if you have some power n, so n is the power. In this case, it is principal fourth root, so 4 here. You have a number base m, In this case, it's 10. And you also have a choice. So which of these choices? So you want to find which of these, and we're going to call this P. And we're going to go through each of these and find one where P to the N minus 1 is a multiple of M. So if we say mod M equals 0. So we're trying to find something that satisfies this. So we want to go through and figure out one of these. I'm moving the background, aren't I? Oops. Yeah, we want to try one of these, which does that. And if you go through, for example, you can do 5 to the 4 minus 1 equals 624. That's not a multiple of 10, which is what we're working with. We're trying to find one of these, which is a multiple of 10. 0 clearly isn't going to be a multiple of 10 because it could be negative 1. We could try with 2. 2 is equal to 15, not a multiple of 10. 6 is 1295, still not a multiple of 10. That leaves 3, which is 80. 80 is a multiple of 10, so our answer is 80. So that situation, whenever you're doing it, you just want to be choosing, filling in these answers. So your principal 4th root 4, modulo 10, 10, and then go through each of them until you find one that is in the base of M, or which satisfies this condition. Oh, that was very blurry for a second. Okay, which of the following describes a unit quaternion? So a unit anything is something with magnitude 1. A unit quaternion is similar. If we're trying to find which of these has a size of 1, and handily Wolfram Alpha has that, where we can just put in each of these following the word quaternion, and it will figure out what we're trying to do. So we say quaternion, and then, for example, I'll get the question up in my notes so I can copy one over. There, so we can say 0, 1, 0 cos of 2 pi. And you can see the norm, that's what we're looking for. We're looking for norm of this is that, and that's not 1. Where's my mouse? There we go. This is not 1. So the idea is go through each of them until you find it. I'm not going to go with all of them because that's going to take forever. I'll say that 0.5, 0.5, 0.5, 0.5 as a norm of 1, and that's our answer. So when anything like this, I'll tell you doing that. Where's my thing? There. That one. In fact, I'll take a screenshot of that. Oopsie. I moved the background again.
Study with the block and balls.
Push, push, push. There we go. And then highlight this wonderful arrow there. Master of penmanship. Okay, given the complex numbers v equals 4 minus I, which of the following describes the complex number, which is 8 minus 2I over v? We can just put this into a division because we're doing a division of this complex number by this complex number. Get my notes so I can copy them over. Where is this question? There it is. Okay, so math ball is good for this. We want complex numbers, we want binary operations because we have 2 of them. And the first one was 8 minus, that took way too much effort, 2. And the second one was 4 minus 0, 1, because it's just I. And we want to divide them. Yes, compute. And we can see that our answer is 2. So, there we go. And so our answer is 2. Next one. But the function f of x equals x squared times the log of x plus 1, which of the following statements is true? Okay. This one is somewhat complicated to work through, and can be done via Wolfram Alpha. Where's my mouse? That's my mouse. Constantly losing it. Okay, so we're doing x squared times the log of x plus 1. Actually, we're doing f equals. Does it work? Wolfram Alpha work for this? It does.
I usually use it for this, yeah.
Okay, so we can see that this is what we were working. This is the r f of x. And what we're trying to do is say our first bit of the question is the range of the first derivative. I believe that's what that means. Is the positive real numbers. This is again first derivative. These ones aren't, so we'll look at this. This one does care about the derivative though, so we'll look at that. So fx has the critical point, which is maximum, and the critical point, which is minimum. Second there. So for that, we need to be looking at the first derivative. That should be this, I believe. So this is the way to. There we go. Okay, and this is our first derivative. We're looking at this. So the range of this is the positive real numbers. We can look here, even tells us the range. All non-negative real numbers. No, negative and positive aren't the same thing, so it's not the first one. It's not this one. All of the cases which f... how do you say that? Never actually tried to say it before.
It's just the first derivative.
First derivative x. That's really long. Okay, for which the
I'd
first
say
derivative
f dashed.
That works, f dash. Okay, for all the cases where f dash of x equals 0, cannot be classified as minima or maxima. So we're looking
Alternative is f prime, just saying. So I've
F
heard that
prime.
one.
Yeah, I've heard that before, yeah. F prime is nice. Okay. So we're looking for if the cases as a minima or maxima, where x is 0. So the question is, are these minima and maxima? Now, we can see that this... I forget the rules for something is a minima or maxima. I think I have written them down. One moment. No. Okay, I'll get them up at the end. Okay, we'll continue with the rest. f of x has no critical points, cases for which this is 0. This is false because it does have one of those. We can see there's a case here where it's 0. Which means it has a critical point. It has a critical... and we can only say this one. So these two are this. And the answer is this one. I need to figure out why, though. So we'll come back to this at the end. So I look up why. Because I forgot to write that down. Next one. Starting from a point 3075, a vehicle climbs to a position 40225. What is the vehicle's horizontal position when it reaches a height of 150? Few ways you can do this. You can calculate the line equation using the numbers, and then use that, rearrange for x, and stick the x in. Or you can just stick the numbers in Wolfram Alpha, and it'll tell you. Should we do... Let me get this thing up so I can get the numbers. There we go. We are looking at the position 3075 and the position 40225. We put that in, it will graph it for us. There we go. We have this graph. And we can see that we are looking at position... we're trying to find the x when the height, the y, is 150. Coincidentally, that is the midpoint, so it just tells us it's 35. Alternatively, if it happened to be that the position we're looking for wasn't the midpoint, and therefore it didn't tell us, we could just take this equation, rearrange for x, and then stick in whatever our y was, and it tells the x. But as it stands, we can just do this. And see that it is 35. A company uses a formula to decide annual expenditure on advertising and promotional material based on the average customer spending and production costs. This formula is given by that promo x of y equals x squared plus y squared minus x times y minus 20x minus 8y. And which of the following statements is true of this function? So the first is that it has no minima. Second, it has no critical points. Third is that the only critical point is when both are 0. And okay, the minimum spending is when. Okay, so one is when the minimal is at this position, minimum is on this position, and the other is that it has no minima, that it has no critical points, or that it does have only one critical point, which is at the origin. We can find all of this by, again, sticking it into Wolfram Alpha. Very nice tool. So it is x squared plus y squared minus x times y. Let's divide by x times y minus 20x minus 8y. We can see it picks this form. We can go down once it produces the rest. We can see it's there. It's got different forms. We're looking for. Where is it? There we go. It has a global minimum at 1612. And if you look at the questions, the minimum spending outside is when x is 16 and y is 12. So it's this one. You have to look at the rest. I moved the background again. A robot drone descends from a point 50 or 180 to the base of a hill located at point 7530. What is the gradient of the corresponding line? Well, gradient of the line is the change in y divided by change in x. We can just calculate this manually. It would be 180. Yes. So that, yeah, it would be 180 minus 30. We want to do the y first. And all that divided by 50 minus 75. Stick down the calculator and you get negative 6. Which is this one. That's the gradient of that line. Alternatively, could have just stuck the two values, the two points into Wolfram Alpha and it'd tell you, giving you the line equation.
For this one, I know we said we weren't going to cover it, but I think I can explain how to find the answer. I don't understand the like how it works, but I can find the answer. So
okay, you think you know.
Yeah. So we've got a parameterized curve. We've got an equation which is integrated between 2 points, and we need to find a possible parameterized curve for that integral of that equation. So the way we go about this is we need to look at which of the possible equations will satisfy which of these formulas will be true for our points. not sure how to explain it. Which of these formulas work for both points A and B? So we can plug in 0, then t, where t is how to explain it. So if we plug in 0 into this first equation, then we get c of 0 is equal to 0 plus 0i, which is obviously 0, which is a. And if we plug in 1, then we get 1 plus I1, which is just 1 plus I, which is equal to B. So what we're looking for, a better way of saying it, is we're looking at which of these functions you can provide a t to get the points that we're looking for. And we're looking for the simplest one. So for both of these first two, 0 and 1 would work, because for the second one, obviously the 1 squared is just 1, 0 squared is still 0. But for the rest of them, you could plug it in if you wanted to. You'd get different results. They wouldn't match A and B. So we could tell it's the first one, because these two both work. You can plug in a number to get both A and B for these, and the first one is the simplest. I don't fully understand parameterized curves, but that's how you find the answer to those questions.
So does 0 and 1 come from the real parts of A and B?
If they might do, that would make sense.
Okay.
Yeah, that is true.
Okay, that helped me as well. Okay, so there was, I think that was the last one? Yes, that's the last one. So does anyone have questions? I actually don't have the chat, but let me...
Do you want to go back to that question that you didn't finish up?
Yes, which one was that? It was this one, was it?
I think so.
Yes.
Yeah, it was that one.
Gonna have to give me a second to Google this. If anyone has any questions, put them in the chat, and then I'll try to get to them while I'm Googling this.
Do you guys know how many questions are going to be in the actual exam?
I don't. I can see if it's worth 60 points.
Okay.
Doubt there's going to be 60 questions, though.
Maybe 30, I'm guessing.
Yeah, that would make sense.
Yeah. All right.
Cami, any chance you could scroll to the end again? I feel like I can explain parameterized curves better than I did.
Okay.
So a parameterized curve is a function. In this case, we're using C, which takes a in an integer, but well, not an integer, a value. Takes in the real value of a complex point, and then the function maps it to the whole complex point, if that makes sense. So C, we take the real of, for example, A, then it maps it to A. So you give it the real part and it gives you the full complex number. So for example, in this question, we do C0 because that's the complex part of it, the real part of A, sorry. We plug that in, and we get 0 as a result, which is A. So what we're really checking for here isn't that there is a number that works. We're checking that if you put the real part into the function, into C, then you get the full complex part. So still, it's the top two that work and you choose the simplest one. But it's important to note that you're plugging in the real part and get the full thing back. There you go. Just a bit of a clarification.
I believe that the reason for, is it this one, for whether they cannot be classified, is that it is a saddle point. So if we take back this equation, put it back in, my notes so I can find it. No, there it is. Okay, so we want to be sticking in f of x equals x squared times the log of x plus 1. Stick that in, and we get this curve if we take its first derivative, which is this. We get this. And I believe the reason why it cannot be classified as a minimum or maxima is that this is called a saddle point, which would mean that while all of the what's the word I'm looking for? While it is a point which is perpendicular, if you took a tangent of it, it's perpendicular to the x-axis. It isn't a minima. If you were to expand this out, it would be count. It wouldn't count. I believe is the point. The explanation was shaky, but I think that's why you can't classify it as a minimum or maxima. There's a question. The Euler form. Your Euler form. Let's go back to that. That was to the left, wasn't it? One of the first ones. Wait, yes. This one? Yes. Which is the following trace of the equals smaller complex number? The Euler form Q. Yes. So you don't put the full expression. You just put the trigonometric part. So it's cos to negative inverse cos 0.8, and that will give you well, it gives you a fractional number. Inverse cos 0.8 will give you 36.86988976 yada yada yada. Which you can then round up to 37, which when we turned it into a polar form of that number, we did guess 37. So it's just this last bit that you want to be putting in the calculator, because we're just trying to check, does this match this? Match this. If I actually go back, unary, what was the thing? 4 plus 3r. So 4 plus 3i, well, is in polar form, compute. We get this out. And because of the way that the link between Euler and polar form, Euler is the general format of. Where's my pen gone? There it is. Some number, so it's x e to the power of I theta, and cos inverse cos gives theta, and then this for polar form is z equals x times theta I plus theta. No, cos theta. Cos theta plus I times sine theta. So we just want to make sure that the which of these matches the theta, and because these have sine, then you have to also you have to multiply this to actually get the value of the theta rather than that. So theta equals so -1. G7. Anything else? If not, similarly, then I will pause the recording.